In this presentation, we will discuss tidal energy as an alternative energy of fossil. I will briefly introduce the principle of tidal energy and its advantage. Then my group member will discuss the use of tidal energy from three aspects. Tidal energy is taken from the Earth's oceanic tides. Tidal forces result from periodic gravitations in gravitational attraction. Because of this, tidal power is inexhaustible. And due to the consistent pattern of the Earth's rotation and the Moon's orbit around the Earth, the changes of tide are highly regular. The water around landmass is at high tide when the landmass matches up with this Earth-Moon system. These data are tide prediction I downloaded from Australian government website. We can see the change of tide are long-term predictable. A turbine is a machine that usually used to take energy from a flow of fluid. The fluid can be air or liquid. Actually, water is roughly 830 times denser than air, so tidal can generate more energy per unit area than winds.
I present here two main types of tidal energy generation. First, the tidal barrage type of power generation involves the occupation of large areas of land and sea. In order to capture the tidal energy, we need to build the dams and related control equipment. The other method, the tidal stream power generation, is mainly characterized by setting up the turbines directly on the seabed. This method occupies a relatively small land area and is mainly used for connecting the facilities and maintenance of the power generation equipment. Both approaches have their advantages and disadvantages, but both offer the possibility of capturing and converting the tidal energy. Tidal barrage power is a method of capturing and storing the tidal energy through the construction of weir pumps and then releasing it through the turbines at the right time to generate the electricity. The barrage area is the largest land occupation of this technology. The weir pumps are usually built in the coastal areas, often covering the large areas of the ocean or estuary. The structures such as the gates and turbines, which control the flow of water in and out of the pool, also occupy the portion of the land and seabed space. Infrastructure like grid connected power lines, substations, control centers, roads, and other support facilities also occupies the land. Although these facilities are small, they must reserve enough land near the weir pool. The dam pumps may affect the fish migration, sediment movement, and coastal vegetation growth. The tidal power generation is a method of harnessing the energy of tidal currents and converting it into the electricity through the turbines placed on the water. The tidal power generation has less direct land intensification than the barrage power generation, but land and sea utilization issues remain. The tidal turbines use less land but occupy a certain area of the sea floor or the riverbed. Although the main power generation equipment is underwater, the turbines must be connected to the grid on land. This may require the land for substations, cables, and other infrastructures in coastal or river areas. The building access and other facilities to remain and inspect the underwater turbines will require the onshore resources. The turbines can affect the local navigation, fishing, sediment movement, ocean currents, and hydrological conditions.
Tidal energy as a renewable alternative energy source uses the kinetic energy of tide to generate electricity. Therefore, the carbon emission during the whole period of operation of tidal energy generation are relatively small. Tidal energy systems themselves produce no carbon dioxide emissions during the operational phase. The process of converting tidal movement into electricity using turbines is almost carbon-free, as there is no burning of fossil fuels in the process. However, a small amount of carbon emission will be generated throughout the life cycle of the project using tidal energy to power generation. In the construction of tidal energy generation infrastructure, materials and energy are consumed in the production of turbines and generators, and in the construction of underwater infrastructure. Those materials and energy are supplied through carbon emission from process, such as combustion of fossil fuels in the extraction of materials, the engineering of machine, and the transport of equipment. Meanwhile, the energy consumed during during the installation of tidal energy system and the regular maintenance and the repair of the system after it is put into operation will also involve carbon dioxide emissions. In addition, dismantling, recycling, and disposal of tidal energy systems at the end of their useful life will also be followed by carbon dioxide reduction. According to statistics, tidal energy emits only 18 to 35 grams of carbon dioxide when producing 1 kilowatt-hour of energy over this entire life cycle.
So, how does tidal energy compare to other energy sources in terms of carbon emission? This figure on the left shows the worst-case scenario emission for different energy sources, and we can see that the fossil fuels has a higher greenhouse gas emission. And on the right, we can see that tidal energy has a competitively low carbon emission compared to other alternative energy. Both of these comparison is made with life cycle assessment or LCA. LCA has a scope from the production of raw materials, transportation, installation, maintenance, all the way to recycling. And this helps us to see the whole picture of the environmental impact and make an informed and a comprehensive comparison. Now the question is, how does tidal energy compare to each other? A study by Walker et al. Conducted a life cycle assessment on 4 different tidal energy devices: full mill, open hydro open center turbine, TGL deep gen, and Scott Renewable SR2000. The condition and location of these 4 devices are assumed the same for fair comparison, and the scope of this LCA is from the production of raw materials all to recycling. As a result, full mill has the lowest CO2 emission out of the 4 devices, and the biggest cost of it is the materials. Full mill is made of PVC foam, which has a lower mass. This leads to a more simple construction and resulted in lower energy use and lower carbon emission. And full mill also has the shortest payback period for energy and also carbon. Therefore, there are various factors that need to be taken into account when designing tidal energy device, planning the assembling, the installation, all the way to recycling process to optimize the carbon emission reduction.
According to the estimation of relevant models, global tidal energy is enormous but unevenly distributed, and Australia is the richest one with a share as high as 22%, mainly concentrated in Northern Australia and Tasmania. Theoretically, if we can use all of the tidal energy, it can meet the demand of all Australian industries. So the reaching the potential tidal energy is one of the advantages of applying tidal energy in Australia. Australian Renewable Energy Agency, or ARENA, is also interested in this clean and power ocean energy. The agency has supported several projects to assess the feasibility of tidal energy in Northern Australia and Tasmania, and most of them prove its possibility in engineering and economic aspects. Besides, the political environment is also friendly to developing tidal energy. Recently, the Australian government tends to significantly improve the weight of renewable energy to reduce carbon emissions and promote energy security. However, there are always some limitations to apply new things. For tidal energy, there are 3 main limitations in Australia. First, Australia has plenty of clean energy like solar and wind. Compared by cost and efficiency, tidal energy is not always the best choice. Secondly, the power grid of Northern Australia and Tasmania is not connected with other areas. This situation will limit the electricity transporting of tidal energy stations. The other concern is environmental impact. Lots of assessment points out that the construction will impact the local marine ecology. However, it's possible to use tidal energy at a specific reach. So to sum up, tidal energy is steady and predictable energy that transforms seawater's periodic level change into electricity. As energy relies on the ocean, the cities will be built on the water bodies and occupy limited land, but may influence heavily on water bodies or seabed. As a clean and renewable energy, it produces minimal carbon dioxide in electricity generation, and the possible carbon footprint only exists in construction stage. Australia is rich in tidal energy resources, considering the coast and benefit. Northern area and Tasmania are suitable for the usage of this energy, but there is still much space for improvement to ensure high efficiency and energy security. That's our reference. Thank you for your listening.